Hey, geometry. I'm here today to talk to you guys about topic 11, which covers isosceles and equilateral triangles. Let's start by talking about isosceles triangles. Isosceles triangles have two sides that are congruent, and those two sides are called the legs. And isosceles triangles have two angles that are congruent. The two angles that are congruent are called base angles. Now, I'm going to work with the isosceles triangle I sketched over here. I am going to put some tick marks on the congruent legs. The tick marks means that those sides are congruent. All right, let me label the congruent legs right there. Those are the congruent legs. All right, and then let me go ahead and put some curves on these angles right here. Those curves mean that those angles are congruent, and those are the base angles. So an isosceles triangle has two congruent legs and two congruent base angles. There are a couple other ways that we could see isosceles triangles. Let's say that we look at an isosceles triangle and we see that just the two legs are congruent, either by the tick marks or they're congruent because they've got an equal number. Well, as long as the two legs are congruent, we can assume that the base angles are also congruent. So we are going to assume that base angles are also congruent. And again, the base angles in that triangle would be there and there, and the base angles in this triangle would be there and there. Well, on the other hand, let's say that we looked at an isosceles triangle and just the base angles are marked as congruent, either by the curves or because they've got an equal measure. As long as the base angles are congruent, we can assume that the legs are also congruent. And remember, the legs would be those two sides, those two sides. As long as the base angles are congruent, you can assume that the legs are also congruent. All right, so that brings us to our first example problem. This example says, solve for x and y. We've definitely got an isosceles triangle because the two legs are congruent. So the very first thing that we can assume is that the base angles are congruent. The base angles are x and 68. So I'm going to go ahead and say x equals 68. And this is friendly so far because we don't have to do any algebra. So x equals 68. All right. But now we still need to find y. We are going to use the triangle sum theorem to find y. Remember that the triangle sum theorem was what told us the three angles inside a triangle add up to 180. So I'm going to take x and I'm going to add that with 68, and I'm going to add that with y and say that equals 180. Now, we know that x is equal to 68. So I'm going to substitute that right in here. And then say 68 plus y equals 180. And from there, I'm going to combine like terms. 68 plus 68 makes 136 plus y equals 180. Now I'm going to subtract 136. Takes care of that. So y equals 44. So in this isosceles triangle, both of the base angles are 68. And to make sure we get a total of 180 for those three angles, y is going to be 44. Now I've got another example for us for isosceles triangles. This example says solve for x. We can tell that this is an isosceles triangle because the two base angles are congruent. And when the two base angles are congruent, we can assume that the legs are congruent. The legs in this picture are the ones with 7x minus 15 and 3x plus 5. So since those are congruent, I'm going to put them equal to each other. And then I'm going to solve. I'm going to start solving by subtracting 3x. Get 4x minus 15 equals 5. Add 15. Takes care of that. 4x equals 20. And divide by 4 to get x equals 5. So in this isosceles triangle, x equals 5. If we wanted to, we could plug this value back into those expressions, and I believe we would get 20 as the length for each leg. Now we've got a challenge problem. This challenge problem says solve for x and y, and in this picture, we've got two isosceles triangles stuck together. The first variable we are going to solve for is x. So I am going to highlight the triangle that x is within. So that we can just focus on that isosceles triangle first. Now we can see that the congruent legs are marked for us, and one of the base angles is marked for us. Well, I'm going to go ahead and mark the other base angle, which is the one with x. So if base angles are congruent, that means that that base angle is also worth x. So for this green triangle, we are going to do the triangle sum theorem. Which tells us that the three angles inside a triangle add to 180. So I'm going to take the two base angles, which are both x, and I'm going to add that with 72 to equal 180. And then I'm going to solve that by combining like terms. X plus x makes 2x plus 72. Oops. All of my highlighters just collapsed there. Sorry about that. 2x plus 72 equals 180. And then I'm going to subtract 72. Takes care of that. So 2x equals 108. And I divide by 2 to find that x equals 54. So what I should definitely do here is put 54 degrees in there, since we've still got a second triangle to work with. Now, if you notice, these base angles each had one curve on them, and as we move into the second triangle, that angle also has one curve on it. So you know what? I'm going to be using 54 degrees for that angle in the second triangle. Now, I'm going to highlight the second triangle in pink so that we can just focus on that one now. Now, the tricky thing about the pink triangle is that the angle with 54 degrees isn't one of the base angles. The angle with 54 degrees is not one of the base angles. The base angles in the pink triangle are the angle with y and that angle right there. Those are the base angles because if we tilted this picture so that we've got the orientation of the legs correct, right underneath those are going to be the base angles. So rotating your paper might be important here to identify the correct base angles in the pink triangle. Now let me rotate it back. Since these two angles are the base angles, that one's going to count as y as well. So once again, I'm going to use the triangle sum theorem. And I'm going to take the two base angles, y plus y, and I'm going to add that with 54 to equal 180. I'm going to combine like terms. Y plus y makes 2y plus 54 equals 180. I'm going to subtract 54. Takes care of that. So 2y equals 126. And divide by 2 to find that y equals 63. So, long story short, for that challenge problem, we wanted to work with one triangle at a time. We ended up using the triangle sum theorem because we knew the angle that wasn't one of the base angles. So x ended up being 54 and y ended up being 63. All right. Now for the last section of the notes. These are going to be about equilateral triangles. So here's the deal with equilateral triangles. All sides are congruent, which of course means equal, and all angles are congruent. Now, when I say that all angles are congruent, that means that each angle measures 60 degrees. If the total inside the triangle is 180, divide that by 3 so that each angle is equal to 60. So, on the picture of the equilateral triangle that we have, I'm going to put 3 tick marks so that we've got the congruent sides, and I am going to put a curve on each angle to show that each angle measures 60 degrees. There are some other ways to see equilateral triangles. For example, we could look at an equilateral triangle and just see that all sides are congruent, either because of the tick marks or because they've got equal measures. Well, in this case, we can assume that each angle measures 60 degrees. So we're talking about each angle in there measures 60 degrees. The other way we could see an equilateral triangle is over here, where we've just got each angle marked congruent, either by the curves or because each angle measures 60 degrees. So in that case, we could assume that all sides are congruent. So we're talking about all 3 sides. We can assume that they are congruent. All right. So we've got a couple examples to finish up here. This example says solve for x, and in this equilateral triangle, we see that all 3 sides are congruent. So that means we can assume that each angle measures 60 degrees. And the angle that we are working with is 10x. So we are going to put 10x equal to 60. And all we need to do here is divide by 10. And we find that x equals 6. And we could always plug that value back into the triangle to confirm that 10 times 6 does make 60. So that's all for that example. And then we come to the last one. This one says solve for x and y. So in this equilateral triangle, we just have all three angles marked congruent. So we can assume that all sides are congruent. So the sides we have to work with are 3x plus 4, 6y minus 2, and 40. Now, it wouldn't do us much good to put 3x plus 4 equal to 6y minus 2 because we've had too many variables there. So 40 is going to be really important for us. Each of the sides is congruent to 40. So I'm going to set up 3x plus 4 equals 40. And I'm also going to set up 6y minus 2 equals 40. And now I'm going to solve those. 3x equals 36. Divide by 3 to find that x equals 12. And for this one, add 2. Takes care of that. 6y equals 42. Divide by 6. To find that y equals 7. So x equals 12 and y equals 7. We could take those values back to the expressions, plug them in to verify that we do get 40 for each of those sides as well. So that's going to do it for topic 11, isosceles and equilateral triangles.